We're going to tell you about the chemistry of arsenic.
Oh my goodness!
It's a fascinating element. Very poisonous compounds, murders have been carried out with it. It has some very nice connections with ancient wallpaper, and Neil is going to show you a whole series of experiments. The books say that arsenic looks metallic, but our sample looked a bit brown. So Neil heated it in a test tube. Arsenic's interesting. It doesn't melt, it sublimes when you heat it. That is, the vapor is formed and condenses on the side of the vessel. And if you look carefully, you can see it makes a very nice metallic film, often called an arsenic mirror. Arsenic is particularly famous as a poison. People used it to get rid of their lovers, their wives, or just awkward people. And the compound they used is arsenic oxide, As4O6. Now, we didn't have a sample of this, so we decided that Neil would make some for us. So he began by dissolving arsenic in dilute nitric acid. There's quite a violent reaction, lots of bubbling, and it forms the gas NO, nitric oxide, which is colourless, but it reacts with air to give nitrogen dioxide, which is brown. So you can see brownish fumes coming out of the test tube. The textbooks say that when you dissolve arsenic in nitric acid, you make a solution of the oxide we want, the poisonous oxide. It's meant to taste of sugar. Neil set up a very nice filter system, poured the solution in, and it came through, though I must say it did still look a little brown. But we were really hopeful we were going to get our white powder. The next stage, of course, is to go from solution to solid, so you have to evaporate off the water. It was a bit slow process. I got bored and went out while Neil was finishing it.
That's pure failure.
What a disappointment. Instead of this lovely white powder, there was some sticky brown solid. I presume because we've still got some particles of arsenic in the white powder. At least we tried. But I still think it's probably arsenic oxide. The reason they used arsenic oxide was they could easily get it. It was a white powder, it tasted sweet, so it wasn't very noticeable if you mixed it with sugar. So our brown stuff is not going to be much use for poisoning people. Fortunately, we're not going to try. I have two favourite stories about poisoning. Both of them are true. The first one happened in a town in the north of England called Bradford. It happened in 1858 in October. In those days, sugar was quite expensive, so people who made sweets were very dishonest and added some cheap powder to the sugar so that they didn't have to put so much sugar in the sweets. They called this white powder daft. On this particular occasion, a sweet maker called John Neal sent his lodger to go and get some daft to put in his next batch of sweets. He called them lozenges. And he went to the next town and went to a pharmacist, and the pharmacist told his assistant to go and fetch the daft, which was a white powder. And unfortunately, he didn't explain correctly, so the pharmacist sold 12 pounds, that's 5 kilos, of arsenic oxide to the unfortunate customer. This was mixed in with the sweet mixture, and more than 20 people died of arsenic poisoning in Bradford, and more than 200 were really ill. And this was one of the things that led to a greater control of arsenic in the United Kingdom. The other case took place in the early 1920s in a town in the west of England called Hay-on-Wye. The attacks were carried out by a solicitor, a lawyer, who in fact was the only lawyer who's ever been hanged in the UK. It is believed he poisoned his wife with arsenic over a period of several months. And then one of his business rivals was invited to tea. The lawyer passed a scone, a little cake, in his fingers to his rival. And as he passed it, he said, "Excuse fingers." And in that moment, it is believed he put arsenic on the cake. His guest was very ill and was found to have been poisoned with arsenic. So they exhumed the body of his wife, dug it up, and it was full of arsenic. So he was tried and convicted and was executed. And it should be said that he always denied that he had done this, though when he was arrested, he did have arsenic powder in a packet in his pocket.
Did he have good white powder or brown sludge?
He had nice white powder. The question is, how did they find arsenic in the body of his dead wife who'd been under the ground for several months? And it's with a very clever test that was invented in the early 19th century called Marsh's test. And Neil decided he would like to do Marsh's test too. The first thing you have to do is to add metallic zinc. I was really excited. I was allowed to chop up the zinc. You put in the pieces of zinc into a round bottom flask, and then you add whatever you think contains arsenic. In our case, a small amount of Neil's brown sludge. And then from a dropping funnel, you drop in dilute sulfuric acid, and the sulfuric acid reacts with the zinc and generates hydrogen. And the hydrogen reacts with the arsenic and makes a compound which has a similar formula to ammonia, but it has 3 hydrogens attached to arsenic rather than 3 hydrogens attached to nitrogen, which you have in ammonia. And this compound called arsine is very volatile. It's a gas. As the hydrogen streams off the reaction, it takes the arsine with it. You're then meant to light the stream of hydrogen coming out of the nozzle at the top of the apparatus. If it's just hydrogen coming out, it would be colourless. And Brady was absolutely convinced that we would see a colourless flame, and he could tell us how bad we'd been at the experiment.
Oh my goodness! It works! I can't believe it worked. That's amazing.
Yes.
You happy?
Yes. So the murderer is guilty, Martin.
Much to all our surprise, the flame came out a beautiful lavender colour. Lavender is the colour that arsenic burns with. But the real elegance of Marsh's test is that if you put a cold surface, a piece of glass or a piece of porcelain into the flame,
It's alright, at least we got it on film.
the arsine does not burn completely, so you get a thin film of arsenic on the surface. The importance of this was that once the film's there, it will stay there, so it could be taken to court to be shown as a piece of evidence. And you could say, look, arsenic came out of the woman's stomach, or whatever the sample was that you had. There's another completely different way that people in the 19th century were poisoned by arsenic, and that was from the green colouring, the green pigment that was used in their wallpaper. This green pigment is a copper salt called Scheele's green. It is made by taking a solution of sodium metaarsenite, which is colourless, and dropping in copper sulfate, which is blue. I've done this reaction several times, but I haven't done it for a long time. And I was really surprised quite how beautiful it is seeing this green solid forming. Scheele's green was used quite widely. This would have been fine, except in those days people were really frightened of drafts, and they used to close all the windows and doors and have very stuffy rooms, which were not very well heated. So particularly at night when they were asleep, there was a lot of condensation and mould would grow on the wallpaper. And so the mould growing on your wallpaper could create a gas containing arsenic, which if you were lying asleep in this airless room, over a period of just one night would be enough to kill you.
In October 1815, Napoleon Bonaparte was brought a prisoner to the island of St. Helena in the South Atlantic. Here he was to spend the last 6 years of his life. Here he died on the 5th of May, 1821. Examination was made of specimens of hair said to have been taken from the head of Napoleon both before and after he died. The results established the presence of arsenic.
My friend David Jones, who was an expert in really weird chemical facts, wondered whether the stories of Napoleon being poisoned with arsenic by the wicked British could in fact be due to mould on the wallpaper in his house on the island of St. Helena, where he was exiled. And remarkably, David managed to get hold of a sample of Napoleon's wallpaper, which had some green marks on it. And he could analyse this and show that it did indeed contain arsenic. And there was enough arsenic in Napoleon's wallpaper to explain the arsenic that had been found in his hair, but not enough to have killed him. So, according to David's experiments, the British did not poison Napoleon, but he just felt unwell because of his green wallpaper. The action of mould on arsenic compound was exploited for real chemistry by an Australian chemist called Bruce Wilde and his technician Paul Gauguin. They did a really unique experiment. They got some bread and injected it with an arsenic compound that was not volatile, and then put the bread in a large container and let mould grow on it. The mould converted the arsenic compound into a volatile compound, a gas. Then they led this through a tube into a solution, and they got a yellow solution of a new complex. And the reason they used the mould is because, unlike human chemists, the mould could produce a so-called optically active compound, that is a left-handed version of the molecule without the right-handed one, whereas ordinary chemists produce both at the same time. And they published a great paper, and they had an extraordinary photo of Paul the technician holding this loaf of bread full of arsenic. I dread to think what their safety assessment looked like. This piece of metal has an extraordinary story about it, which involves arsenic. When I first came here to Nottingham, one of my colleagues, Mike, was studying the reactions of arsenic with liquid fluorine. If it's done carefully, this is a nice controlled reaction. You have to do it with the apparatus cooled in liquid nitrogen. So he was doing the reaction inside a thermos flask that looks like this. And something went wrong, and there was an enormous explosion. All that was left of the thermos was the plastic top and this piece of metal. Everything else was distributed around the lab. But I think the importance of this is to show you that arsenic, if you get it in the right state, or perhaps I should say the wrong state, can react very violently. I went into the lab before it had been cleaned up and retrieved this because I was just so amazed by it. and I used to use it when I was teaching about arsenic chemistry. Apparently, metallic arsenic can occasionally be found in natural minerals, but usually it's found as compounds. And in our store we have a sample of one of the minerals containing arsenic that's called realgar. It's an arsenic sulfide, which has really very nice red crystals. Unfortunately, our sample has rather small crystals, but if you look at them under a microscope, you can see really nice red crystals, which are of arsenic sulfide. And this is probably why arsenic compounds were known even in ancient times, because of these brightly coloured minerals. While we were filming, Neil found some amazing old papers, lead acetate papers for testing for arsenic. They were labelled 20th of July 1942, before any of us were born. So we tried these papers out, tried testing them on some of Neil's mixtures that he'd made. We were expecting the papers to go black. However, nothing much happened. We haven't thrown them away because one of you may know how to use these papers, or we may find out some instructions.
And because Martin doesn't throw anything away.
It is said that arsenic was discovered by a German bishop called Albertus Magnus, who is buried in the city of Cologne in Germany. And about a year ago, I gave a lecture in Cologne, and the students took me to see his grave, and they made a couple of little videos of me looking at it. Not as professional as Brady or James, but still quite fun. Albertus Magnus has real significance in Cologne to current PhD students. There is a tradition that when they graduate successfully, when they finish their doctorate, they go to his statue and they touch his thumb as a sign of good luck for their future career.